This is Misconceptions in Electrolysis for Year 10 Chemistry. I'm going to show you 3 exam questions and explain the misconceptions that students have when answering those questions. First one is about the core practical. That happens in the electrolysis topic. And the question says, copper sulfate solution was electrolyzed using copper electrodes. Draw a labeled diagram to show the apparatus that can be used to carry out this electrolysis in the laboratory. All we're after here is a diagram showing a complete circuit, emphasis there on the complete circuit. It must have electrodes and it must have a power pack. So a diagram like this would be ideal with a power supply at the top, 2 electrodes in a single container with contact with the copper sulfate solution. For the marks, we just need to label the electrodes and we need to label the power supply. The examiner then says, diagram drawing is an important skill, and this perhaps has been overlooked by some judging by the quality of those diagrams. Here's the thing, if you have a core practical, you need to be able to draw a diagram that's labelled to represent that apparatus that you used in the lesson. The examiner goes on. However, there are many that were drawn well and clear, showing a working diagram with the electrodes sitting in the copper sulfate solution and connected to a power supply. The question asked for a diagram to show the apparatus used to carry out electrolysis, and so there's a power supply had to be shown. In addition, it was expected to see a complete circuit, and any significant break lost 1 of the marks. So here's an example of the question, and I'm attaching the mark scheme with it. As you can see, you have the power supply, and you have 2 electrodes, but they're in separate containers. How many marks would you give this? In actual fact, the examiner gave it 0 marks for 2 reasons. The first one, it's not a complete circuit. At the top here, there are big gaps to the power supply, so it lost a mark for that. And then the second reason why it lost the marks is because it's 2 separate containers, and the 2 separate containers means it's not a complete circuit, it's not a workable diagram, therefore only worth 0 marks. Here's another example of what the student wrote. You got your power pack. No, it's not the symbol, the circuit symbol, but that doesn't matter. A box with label power pack will do for this. And we have the 2 electrodes, and they're in contact with copper sulfate solution. So far, so good. However, it's only worth 1 mark because the electrodes are touching. And by making the electrodes touch, there would be a short circuit, and that would stop it working. So you get 1 out of 2 for that one. Just to remind you, this is a diagram from the textbook. You can keep it quite simple. Power supply at the top. Make sure that wires are connected to the power supply and they touch each of the electrodes and that you've labelled the electrodes. Another question on the core practical. Before the electrolysis, the masses of the electrodes was determined. After the electrolysis, the electrodes were washed and dried and their masses redetermined. Figure 6 shows these masses and the resulting changes in the masses of the electrodes. And underneath the table it says, explain these results. Here's the answers. So the anode lost copper and the cathode gained copper, or you may have said the electrode at the cathodes reverse the reaction at the anode, or you may have said the copper ions move into the solution at the anode and the copper ions move out of the solution at the cathode. That's 1 mark for the explanation. The second mark is getting down to higher tier level. If you talk about the fact that the copper atoms become copper ions, 1 mark. And if you say it mentions they lose 2 electrons at the anode, that's worth a mark. Alternatively, at the cathode, the fact that the ions become atoms, that's worth a mark, and they gain 2 electrons. You'll notice an alternative to that phrase, that sentence, is just to write a half equation. If you do the half equation, you get those last 2 points automatically. Now, the examiner said that some people just restated the contents of the results table in an alternative way. So if I go back to the results table, they'll have just said, anode starts at this mass, finishes that mass, and this is the change. The cathode starts at this mass, finishes that mass, and that's the change. You get 0 marks for that. All you've done is restated the question, and you don't get marks for restating the question. The examiner then goes on to say, not all the candidates mentioned the number of electrons that ions need to gain in order to form the atoms, and they didn't mention the number of electrons removed when the copper atom was emitted. That number 2 is important for this question. At the very bottom, and this is a big tip here, the stronger candidates made use of correct half equations. So here's an example of a typical student response. It says the cathode is a negative electrode. There was an increase in mass, which means the cathode gains ions. This gives it a neutral charge. The anode is a positive electrode, and there was a decrease in mass, which means the anode lost ions. This gives it a neutral charge too. Here's the thing. The ions that moved in solution are not identified. And what was happening at the two electrodes lacks all the detail needed, so it gets 0 marks. This is a much, much better answer. As the electrons are copper, they are non-inert, meaning that they will take part in the process. The anode loses mass as the copper ions leave it during the reaction, as it is positive. Cathode gains copper atoms as it is negative, so the mass increases, and then they give the half equations, and the half equations are correct, and that'll be worth the full 4 marks. Here's the examiner tip. Make sure you can write half equations for the reactions taking place in the reactions that you've studied. They are all listed in the textbook. So at the bottom here, I've put down the equations that you need for the copper electrolysis, and you need to know both. When sodium sulfate is electrolyzed, using inert electrodes, hydrogen is formed at the cathode. So this is another question. Write half equations for the formation of hydrogen gas from hydrogen ions. So the formation of hydrogen gas means that this must be the product, and it's from hydrogen ions, making that this is the reactant. And so the reactant starts on the left-hand side, 2H+, and the product goes on the right-hand side, so that's H2. But then you have to appreciate that we need a pair of electrons to be attached to the 2 hydrogen ions in order to make H2. And that is worth 2 marks. Now, the examiner said half the candidates wrote the correct balanced half equation, which was pleasing to see. But then they go on to say the main errors seen were where the equation was reversed or not balanced. So here's an example of where somebody's reversed the equation. They've put the hydrogen gas, I know it's mentioned first in the equation, but they've put it at the beginning of their answer, when of course it's the product. So this equation, half equation, is back to front, so it will get 0 marks. The next one here, when they've written this, what they've done is they've put the -2 electrons on the wrong side of the equation, and they've not balanced the H+, so it needs to be a 2H+ there. And so it would have lost very good marks there. So, electrolysis. Number 1, practice how to draw equipment, which you've used in core practicals. Learn how to write half equations that you've been used if you're going to be doing the higher tier of the exam. Remember to use any data in any table. Don't just simply copy it out. Don't turn it into sentences. Use words like increase and decrease, and that will make things a lot easier for you.